Welcome to this tutorial. In this session, we'll explore mathematical problems involving the calculation of volumes using the disk method. Specifically, we'll learn how to find the volume of solids of revolution for given curves and shapes. Let's start with our first problem. Calculate the volume of the solid formed when the region bounded by y equals sin x, y equals cosx, and x equals 0 is rotated about the x-axis.
Let's start by drawing the region bounded by the curves y equals sin x, y equals cosx, and x equals 0.
We'll use the disk method to find the volume when this region is rotated around the x-axis. To draw the region, note that y equals sin x and y equals cosx are trigonometric functions. First, visualize the region. The curves y equals sin x and y equals cosx intersect at x equals pi/4 in the first quadrant. This bounded region lies between x equals 0 and x equals pi/4, with y equals sin x as the lower curve and y equals cosx as the upper curve.
The region is bounded by y equals sin x, y equals cosx, x equals 0, and x equals pi/4.
To find the volume when rotating around the x-axis, we use the disk method formula, which is given by pi integration from a to b area of upper curve minus area of lower curve. Here, fx equals cosx and gx equals sin x, with limits from 0 to pi/4. Use the trigonometric formula of cos 2x in the volume integration. Substitute the values of the curves and limits in the formula. The volume is found by subtracting the square of sin x from the square of cos x. This integral simplifies to pi/2. Next, let's rotate the ellipse, x squared/a squared, plus, y squared/b squared, equals 1 around the x-axis to approximate the volume of a football. As the ellipse is symmetric around x-axis, the region is bounded between x equals -a and x equals a.
Use the formula of disk method volume, which is volume equals to pi integration from a to b, yx, squared dx.
Substitute the value of y squared equals b squared, 1 minus x squared/a squared, in the formula of volume and integrate it over -a to a. In the integration a and b are constants, the integration results to the value 4/3 pi of b squared. The volume of solid formed by rotating ellipse is 4/3 pi of b squared. Thank you for your attention, and I hope this tutorial has been insightful.